My name is Jens, and I'm a postdoc at University of Copenhagen at the Center for Basic Metabolic Research. And I'm interested in understanding body weight regulation and the biology of fat mass control and appetite. I'm very happy that I'm being one of the 3 finalists for the ECN Best Thesis Award here in Dublin. So we have known for many decades that body weight regulation and energy balance is regulated largely by peptide hormones. But in the recent 2 decades, it's also become clear to us that metabolites can act as signaling molecules and as hormone-like factors in our blood. So in my PhD, I explored the role of one of these metabolites, lactate, and how it affects energy balance, body weight, appetite regulation, and energy expenditure. And I used mice models for that. So the way people often study lactate and also other metabolites is that they administer exogenous forms of these metabolites, and they do that by giving metabolite salts often that they buy from commercial vendors. And in these metabolite salts, that are ions bound to the metabolites, such as, for example, sodium. And what we observed in my PhD is that when you administer lactate in the form of sodium lactate, then most of the beneficial metabolic effects, they are actually not beneficial. They rather reflect that you induce sickness in the mice because people often administer very concentrated solutions of sodium lactate. And the sodium and the high concentration or the high osmolarity of these solutions drives a decrease in body weight and a decrease in appetite and an increase in energy expenditure, not because you administer the lactate, but because these mice, they feel discomfort or they feel sick from these injections. So the take-home message of the results of my PhD is that if you study metabolite salts, you should control for the counter ions that are bound to these metabolites. And if you inject metabolite salts at high concentrations, then you need to reconsider that and maybe try to increase the injection volume to lower the osmolarity and thereby make it more tolerable for the mice or for the rats or for the humans if you study humans.